right. So today we are going to work on situations where we have monomials. So just like our one term. Monomial means we have like a term, like 5x squared. Monomial, okay? So we're going to talk about when we are multiplying. So this is called the product rule. We call it the product rule because we are multiplying. So product, okay? So look at this. If we have two things being multiplied and they each have the same base and we're multiplying, then the base stays the same and we are going to add our exponents. Correct. Okay. Let's maybe talk about why that is. So here's this guy right here. So if we do what I just said we needed to do, this would become, we keep the base of 4, and then we take 3 plus 8, which is what? Okay, so let me demonstrate that. If I take 4 cubed, that means 4 times 4 times 4, right? And if I take 4 to the 8th, that means 4 times 4 times 4, 8 times. Okay, well, people, how many 4s do we have multiplied to each other? 11. And how did you do that? You counted them up. You added the number together. Okay, so without having to draw a picture, we know that there are 3 4s being multiplied here. We know that there are 8 4s being multiplied here. So total, we have 11 4s being multiplied together. All right, so let's look at number 18. We are multiplying. That is good. Is our base the same? Yes. -7 is our base. Okay. Since we're multiplying, we can take 4 and 5, our exponents, and add them together. So this is the same thing as -7 to the 9th power. Wasn't so bad, right? Okay. Now, number 19. Ooh, what do you notice? There's a negative. Does that change what we do? No, it does not. Okay. We are still, since we are multiplying with the same base, we're going to keep the same base. And we are going to take our exponents and we are going to add them together. Ryan, what is -6 plus 2? 4. Okay. Now, we learned about negative exponents last week, and I want to remind you that we cannot keep a negative exponent in our answer. So my expectation is that you would write this as 1/2 to the 4th. Okay. When we have a negative exponent, we have to rewrite it on the other side of the fraction bar. Okay. So let's do this. How about you and your elbow partner work together on getting answers for 20 through 22? Yep. There's that next line. Okay, let's talk about these. Number 20. Tyler, what do you have for number 20? 15 to the what power? 7. Does anybody disagree with 15 to the 7th? You disagree? Oh, okay.
No, we're good.
Okay. Remember, if there's no exponent, it's an implied 1. So we have 1 plus 6 is 7. Okay. Bronson, how about number 21? How did you get 1 over 5 to the 8th?
Oh. Because there's, oh wait, never mind. It's just 5 to the 8th.
Oh, wait, it is just 5 to the 8th power. When we add 9 and -1, we get +8, right? Okay, good. And then 22, Quinlan, what'd you get? Yeah, you're good. You're good? You have this 1 over -1 to the 5th, right? That's beautiful. Okay.
See, I knew it.
If we add those together, -2 plus -3 is -5. Okay. And since she had a negative exponent, she pushed it down to the denominator. That's beautiful. Okay. Now, is our process going to change when we go to variables? Did I? Oh, sorry.
You like walked over here.
Okay. No, it's not going to change our process at all. Okay. So when I have x squared times x to the 5th, everybody, this would be x to the, that was really unenthusiastic, x to the,
Ow.
okay. How about here, Kinley, when we add our exponents, what do we get? Would you say m to the 2? Yep. Yep. Okay. If I take -1 and add it to 3, we get m squared. Okay. Okay. Ooh, 25. Interesting. Well, let's talk about if we add these together, it would be k to the what power? If I add -7 plus 7, it would be k to the 0. And anything to the 0 power is 1. Okay. Okay. Okay, now, you know what? I'm feeling real good about this.
Are you so we get to do our homework?
No, I want you and your elbow partner to work on these 3 that I just highlighted. Just ignore it.
We can't talk out loud. We can't do it with our partner.
What's 4 plus?
You'd have time. Is
What's 9 minus 3, babe?
that a T?
No, plus sign.
How about a multiply sign?
My bad.
Tired and it just hits you right at 11.
I just guessed.
All right, eyes up here, please. Okay, eyes up here. Corin, what's the exponent on this guy? 1. Okay, so what did you do to get your exponent here? What'd you do with 1 and 3 and -9?
I didn't add the one.
Oh, whoops. So this would be 8 to the what power? Help me out. What's 1 plus 3? And what's 4 plus -9? -5. Okay, please make sure that we rewrite this to be 1 over a to the 5th. Okay. All right, now in 27, I saw some interesting things happen. Can I multiply all 3 of them together to just get 1 letter? No. Okay, but x to the 4th times x to the -1st would give us x to the what power? 3. This is still a multiplication sign. It doesn't change. So you can either write it like this, or you could write it as x cubed y. But it does not become a plus sign. I saw some plus signs. That's not what's happening. Okay. All right. And then Arislin, what about 28? What was the first time you added them together, what did you get?
Oh, okay. S times R, the -2.
So
I don't know. S.
okay, so what happens, isn't this x to the 1st and x to the 1st? S, sorry, is it x? So this would be s to the what power? 2nd. Okay, and then Arislin, will you help me? If we take -2 plus -4, what is that? -6. So I want this answer to look like this: s squared over r to the 6th. S squared over r to the 6th. Okay. If there is not an exponent, I would highly encourage you to write a little 1 so that you remember, like, this s to the 1st times s to the 1st is giving us s squared. Okay, well, I can't have a negative exponent. Like that? Okay, yes, technically you could do that, and I would not count you off. What I would really love, though, since this is like an implied over 1, I would like you to combine it to just 1 fraction. Okay, so that was a good question. Thank you, because then I think it was a good thing for me to write this out for you to see that. Okay, now what we're going to move to is sometimes we're going to have some coefficients in our multiplication. Okay, so like in this problem right here, 29. Okay, our coefficients, we still multiply as coefficients. So we know that 4 times 2 is what? 8, right? But then we have a to the 7th times a to the 3rd. Well, when we multiply with our exponents, we're going to take them and add them. Okay, so this would be 8a to the 10th. Okay, I'm not like totally blowing your mind, am I? Pretty mind blowing. Okay. Tyler, how about here? What is 5 times -3? -15. Okay. And then, like I said, if there's an m without if there's not an exponent written, let's write in that implied 1. So if I have m to the 1st, maybe I'll just highlight this in another color, m to the 1st times m to the second, then when we're multiplying, then our exponents get added. So they had parentheses just to separate that negative out. So if you write parentheses, I'm not going to be upset, but they are not necessary. Oh my goodness, there's so much happening here. We're fine. Okay, so what we're going to be doing is we're going to be taking 2 times -7 times 3, and we're going to be taking w to the -1st times w to the 4th times w to the 5th. Maybe that would help your mind to just rearrange all the multiplication. So some of you may have grabbed a calculator because you just knew that, man, I don't want to do mental math today. And that's fine. Okay. Can you help me out with 2 times 7 times 3? Okay. Times 3.
42.
So -42. Okay. Now, what? We can have a negative coefficient. That's cool. Okay. Well, we can't have our negative exponents, so we'll have to be careful. If I take these 3 and I add our exponents together, -1 plus 4 plus 5. Well, I know 4 plus 5 is 9. Plus a -1 would get us 8. What did you say, Brady? Okay. Different than yours. All of our brains work differently. Okay. In number 33, we now have some problems that have A's and B's. No, that's fine. Okay. So we're still going to focus on, we're going to multiply our coefficients together like we usually do. -2 times 6 is -12. Okay. Now I am going to put an exponent of 1 on both A and B since they're not there. It's implied that it's a 1, but I think it's going to help us. So if I have a to the first times a squared, we know that's going to be a cubed. 1 plus 2 is 3. Right? And then if I have b to the first times b cubed, I can take 1 plus 3 to get 4. Okay. We're going to do 2 more examples together, and then I will give you some time to work. Does that sound okay? Okay. In number 35. Okay, so I'm going to go ahead and do this. I'm going to highlight where it says multiply. Okay. I'm also going to do this. I see a C without an exponent, so I'm going to put that implied 1 and this D. Okay. So here are my coefficients, 7, 2, and technically this coefficient is -1. Do you agree? So if I multiply 7 times 2 times -1, that would give us -14. Okay. Now, I have a c cubed times c to the first times c cubed. Okay. So we're just going to take those. We're going to leave the c, but add the exponents. 3 plus 1 plus 3. 7. Okay. Then we're going to take our d's. D squared, d to the first, d to the 8th. If you put a dot for multiplication, that'd be fine. All right, now, the last couple of problems of your homework are gonna look like this. And what I need you to remember is that way back at the beginning of the school year, we really emphasize order of operations. Okay? Multiplication comes before addition and subtraction. So I see an addition sign right here, but I also see some multiplication signs. Those multiplication signs need to happen first. So let's take this multiplication right here. We have this multiplication right here, right? Okay, well, -8 times 2 is -16. K to the 4th times k to the 1st is k to the 5th. Okay. Plus, if we take this multiplication right here, we would get 3 times 1 is 3. K squared times k cubed is k to the 5th. Interesting. What do you notice? What are we left with? An addition problem where they match. Our variable and exponents match, which means we can take -16k to the 5th plus 3k to the 5th for -13. Make sure you do the multiplication before you do the addition and subtraction. And I'll tell you that on your homework on page 7, the last 2 problems are the ones that you're going to need to be careful with. Okay, so on page 7, 12 through 28 is your homework. 27 and 28 are the 2 problems that you're going to need to be careful with PEMDAS and combining like terms. Oh, that is totally fine. You can take -2/3 times -18 and you'll be just fine. You have a calculator, right? Right?
18/1? Or
Yeah.
what? Oh.